Hi, I want to explain about current limit for LED and to simulate such a circuit and explain how it works. So suppose we have a LED and we want to limit the current, so we will need a kind of feedback for the LED. So I will take a resistor that will be the load that describe the LED. So actually I will take just a resistor. Now I will add a power source of 12 volts. So we will go and search for voltage. This is of course LTspice. Right click, it will be 12 volts. Resistance will be 0.1 ohm or maybe 0.01 ohm, doesn't really matter. Now I want to use a comparator in order to limit the current, and I will try to explain how it is working. So I will take any OPAMP that I have here. There is one that I know it's like it doesn't really matter because I will use the OPAMP just as a general part for comparing between the voltage on the negative and the voltage on the positive, since I'm not connecting any feedback. So the comparator will just check whether the voltage in the minus input is bigger than the voltage in the positive input, and then it will do the current limitation. And let's see how to do it. I will move it a little, and now we want a Mosfet as a driver for the LED. So I will use something that I know should be okay. I hope I will find it in the library. Now, okay, we'll go to components, Mosfet. We have here NMOS, and okay, we'll take NMOSFET, and then right click, and we will search for a MOSFET that is good enough. What I need to take in a MOSFET, what is matter is the V threshold, or the voltage that is controlling the MOSFET to open or to close. So I will take let's see, yes, it looks to me okay. Just a second. What is important is the maximum voltage and the V threshold are the most important things. So V threshold of 2.77 volt, and of course the current that it can flow through this MOSFET is 0.6 amp. It looks okay to me. This is of course the model of this MOSFET. Now we will connect the LED, and we will connect the sense resistor. So the sense resistor is actually limiting the current and controlling the LED. So what I have here is just a very basic circuit that will limit the current. So how it is working: the MOSFET is opening, and there is a flow of current from the VCC to the ground, and here the LED, so the LED will get the current. Now let's talk about the limitations. So first I need to connect, of course, the LED to the VCC. Okay, this is the anode of the LED, this is the cathode, and I have here ground, and I will move all this a little. Why it is not picking what I want to pick. I will move it a little like this, so I will have more space. So till now we just connected the LED and the Mosfet that is giving the current to the LED, and we have a feedback resistor. I will take a feedback resistor of 0.5 ohm. Now I found the LED of 9 volt and 400 milliamps. So now I will take this, I will take the voltage from this resistor and connect it like this back to the OPAMP minus input. What this will do is actually, I want to limit the current for 400 milliamps. So I will take now calculator, and if I want to limit it like this, so I will now measure. Okay, so I will take. Okay, so U is equal to I full R. Okay, so okay, I want to know what is the voltage to put on the other input of the op-amp in order to limit the current to 400 milliamp. For this, I will use this very simple formula that is saying, we'll write it here. This is a very simple formula that U is equal to I multiplied by R. What it is saying is that the voltage is equal to the current multiplied by R. But I know now my resistor, which is the resistor that I put here, that is 0.5 ohm, and I know my current that I want it to be 400 milliamps. So now I will calculate what it gives us. So let's see. So if I have 400 milliamps, so it's 0.4, and I have a half ohm resistor, so I will multiply it by 0.5. I get, of course, 0.2 volts. This means that I have to put in the positive pin of this op-amp 0.2 volt. So now let's do it. So how do we do it? We're just taking two resistors and we will calculate the values of this resistor in order to get this voltage. So I will connect now the resistors. One of them will be to the 12 volt positive and the second to the 12 negative. And now let's say I will take a resistor that I know it exists. Let's say 820 ohm. Now I want in this resistor to have at this pin, which I call it the limit. Let's give them a name. So this will be the current limit or voltage limit. So now it's current limit. So we will give it a name, current limit, exactly to this net. And the current limit should be, we calculated it, it should be 0.2 volts. Okay, yes, this is what we got, 0.2 volts. So now I know that I want to have 0.2 volts on this resistor, so I will calculate the current that flows through this resistor. So I know that it should be 0.2, so I will divide it by 820 ohm, and this is the current that I have, and I know that this current should be here. So if I have here, let's maybe write the number. Okay, so I will take now maybe a notepad with a new tab. Okay, and I will write the numbers. So let's do Ctrl C and Ctrl V, and I know that the voltage here, of course, is 12, what I have, minus 0.2, because I know that this is what need to be. So it's give me of course 11.8 volts, and I know that this is the current that should be. So I will take this number, which is 11.8, and divide it by this number. So I will again do copy and paste, and it doesn't work. Okay, I thought it should work, but okay, I will do it manually. Maybe we'll go to scientific, it will be easier. So I have a 0.8. I want to divide it by 2.439, and this is a micro, so I will multiply it by 0.0001 to get it in a micro, and now I will have my resistor value, which is about 48k ohms. So let's put 48k ohms, because I think we have such a resistor. So what I did now is get constant voltage on the current limit that will be 0.2 volts, and we will check it. Now the last thing to do is to connect the output of the OPAMP and to check that I've done everything correct, and then we can build the circuit. So I will take now a resistor, I will flip it by Ctrl R. This is rotating the resistor. Okay, now I will put the resistor, I will give it to be 100 ohm. I will take another resistor. This is just a good habit to do it the way I'm doing now. I'll explain, because I want to Mosfet if something is wrong to be tied to ground, so just connecting another resistor here that will be also multiply divider. It doesn't really matter, but let's say it is 220 ohm. Basically we are all done. Now, believe it or not, the circuit will limit the current. I need to get here another ground for the simulation, otherwise it will not work. So now let's run the simulation and see that it is working. Another thing that of course I forgot is to connect the OPAMP to power, so we are connecting it to the 12 volts here and here. Now it is connected and it has voltage. So now let's run the simulation. I will give it 5 seconds. It's enough, it's a very simple simulation. And now what I'm doing, first I want to check that my limit is 0.2 volts, and it is 200 millivolt at 0.2, so I did the correct calculation. And now I remind you that I want 400 milliamperes on this LED. So I see here, if you will see, we have a little less, no problem. because the resistor is not exactly the LED, so we will change it to 30 ohms and run it again. And we can see that we have near 400 milliamps. Now, what I should do is change the LED resistance and see that even if it is very small, the current will be same 400 milliamps. So if I'm taking the 3 ohms and I'm changing it to, let's say, 15, this is half. Of course, I expect the current, if it is regular circuit, to be twice, because the resistance is half, so the current is twice. So I will put it like this and run it. And I see that it is fixed, okay? The current IR1 is, you can see, is 400 milliamps, because this is what I expect it to be. Now I will change again the resistor to 1 ohm only. Even if it is 1 ohm, and I will run the simulation again, it should be exactly 400 milliampere. This is the current source. So I'm running it again, and I have the same current. It doesn't change. The current doesn't change. So my circuit is working. The OPAMP is limiting the current by enabling that the voltage in the minus and the voltage in the plus will be the same. So the current here, this resistor, will be constant no matter what happen here to the LED. So later I will build this circuit, because I want to build to my flashlight a simple current limit. Instead of taking this part, this is a linear and I have the parts inside linear, I will use parts that I'm familiar with, and I will give you the numbers so you will know what are the parts. So basically for Mosfet you can use any N Mosfet with a voltage that is 15 volts and above and has a current of, let's say, 1 amp. For the op-amp you can use a very regular op-amp, which is LM for 741. This is very general purpose, one op-amp in a package that I'm used to work with, and it will be okay in the same circuit. So hope you enjoyed these lessons, and goodbye and bye bye for next time. Hope you understand. This is a very basic circuit that very easy to design if you are familiar with some parts and MOSFET and OPAMP. Thank you and bye bye.